Okay, we're just going to have a quick run through how filtering works on a full wave power supply.
Excellent, excellent.
So on a power supply, you'd have a plug that goes in the wall.
That's your AC?
That's your AC coming in here on a pair of wires.
Absolutely.
It goes into, there's no switch on this one.
No.
It just goes into the primary of a transformer. And this shows the laminations in iron.
The insulation?
No, the laminations. The irons of the transformer.
Yeah.
And coming off here, we have a center tapped secondary. That's supposed to be the center tap.
Okay. Mm-hmm.
Okay.
That's parallel to...
Tick, 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 tick. And this is a solid state power supply, so we're going to show it with diodes in it.
Okay.
And the output is right here. And this is a return path. So this side will always be negative, this side will always be positive, because when the current flows this way through the coil, and here, it can't flow through here because it can't go through the diode in the opposite direction for which way the diode conducts. But it goes out here through the load externally and back this way through the diode. And on the other half of the cycle, it'll flow this way, out here, back, and through this diode.
And that's a
This side of
negative.
the transformer.
That's a negative.
This is always negative here, this is always positive here, and this is full wave. You may have a half wave in your book.
I do have a halfway, yeah.
It would look just like that.
Absolutely, yeah. What,
Without this other wire. Okay, but the output ripple from this thing would be tremendous. So the input would look like this for 2 complete cycles. The output would look like this for 2 complete cycles. It would flip this up. This,
on the return?
No, it would flip the negative side up, so to speak. So it's always going to be positive here and 0 here, or ground.
Oh, ground, yes, okay.
Negative is ground in most of our circuits here. This is a positive power supply. We'll make this 200 volt positive supply. So this has to be a 110 volt winding or 120 volt winding, and that's 200 volts on this half of the winding and 200 volts on this half of the winding. Now, incidentally, if I made this thing a half wave, I could get 400 volts out of it. You can see how.
2 and 2.
2 and 2, right.
Yeah.
However, we're looking at the ripple in this instance. The output is always positive, but you can see it goes from 0 to positive and down to 0 every half cycle. But instead of going negative now, it goes positive again for the next half cycle. Okay. This is terrible. This makes all kinds of hum in your radio. You don't want that. So you want a filter. And a filter consists of a thing called a pi filter normally. They found out by experimentation. If you take an electrolytic capacitor and put it across here,
parallel
with it,
yeah,
it will filter this out so that if you looked on an oscilloscope now, you'd see this on that oscilloscope.
Yeah, we saw the oscilloscope, right?
It would filter it to look something like that, because you would charge and discharge the capacitor at that rate. It's at 120 hertz per second, actually, not 60 hertz. Here. If you then put in a choke with an iron core, like the transformer, but it's only got one winding, you would then smooth it even more, and your voltages would be like this. So your output would look, it would come up the first time. It's not bad, we're getting there.
It's almost pure, isn't it?
Almost pure. But they found if you put another capacitor in here, electrolytic, all the same as the first one, we'll say,
Right.
that it smooths it off so much, it's like this. So your output would come up and stay pure.
Excellent, yeah.
Because of these three, and that is a pi filter, as in pi r squared, that kind of pi. This is positive, this is negative, negative is normally ground. And there's your positive output terminal. And there's somebody who can explain it to you properly coming into place now.
I got off on 24 volt. That was another thing I was going to ask.
A 24 volt power supply?
Yeah, see how they changed that from 12 volt and then this means that the entire secondary, and you can measure
okay.
across both ends.
This, yeah, see, remember here I had 200 volts here and
Yes.
200 volts here? I said I could get 4.
Right.
They did the same thing there with 24. Now, if I had that same output on a transformer, and instead of using the half tap, I put this circuit in.
Oh
which
yeah,
is- okay, that's called a full wave bridge.
full wave bridge, yes.
And I don't know, we're going to draw this thing somehow. And don't, and
That's another tap.
tick, tick, are we going to use a tap on that? We're not going to use a tap on this.
No.
It's got to go.
4 diodes.
Yeah, I'm just trying to figure out which way now. It's been a long time.
According to the book, the current is going to flow. It's going to flow from right to left, or left to right. Sorry.
I'll take you through this.
Yes, that's right. And then that one goes the opposite way. See this
It's been
one
a
here?
very long time since I've done this, right?
Yeah. Now we're on. That goes the same way. Absolutely.
One out here, and one.
Now this is a resistor here
Oh,
or
here.
something?
That's the load. I should have put that across. This draws the power supply, but
Yeah.
it always has a load on here.
Great.
That's your output load.
Okay.
So this is the output load on this one, and we won't draw the filter on this particular one.
No.
So what happens here? If we had this 200 and 200, we now have 400 here altogether. Or in your case, 12 and 12 is 24
It's
altogether.
24 volt, yeah.
Now, when current flows this way, can't go here, it goes through here, out here, negative, back in here to positive, through here to this side. When it flows this way, it's coming out here, negative again, back up here to positive. Magic. So you got 400 volts instead of the 200 and 200, and you don't use a center tap. See?
Absolutely.
So if you put a bridge rectifier on it, you can get twice the voltage out of it at the same current.
Yeah.
Magic machine. But he's going to take that up tonight anyway, right?
Oh yeah, I hope so.
You know,
I hope so.